Welcome to Section 2.2, Measures of Variability. In this section, we'll explore how to describe the spread of data, which is just as important as understanding the center of a distribution. Variability tells us how consistent or inconsistent our data are. Knowing the center of your data isn't enough. Imagine two drugs that both lower blood pressure by an average of 10 millimeters of mercury. But one drug has very consistent results across patients, while the other has a wide range. Some patients see almost no change, while others see large changes. Understanding variability helps us interpret how reliable and predictable an outcome is. There are three key measures we'll focus on: range, the simplest measure of spread; variance, which quantifies average squared deviation from the mean; and standard deviation, the most commonly reported measure, which expresses variability in the original units of the data. We'll also briefly mention interquartile range, IQR, when we discuss box plots. Let's start with the range. It's simply the difference between the maximum and minimum values in your dataset. For example, if the youngest patient in a study is 18 and the oldest is 75, the range is 75 minus 18, or 57 years. It gives a quick sense of spread, but is highly sensitive to outliers, since it depends only on the two extreme values. It's rarely used as the sole measure of variability in scientific reporting. Now on to variance. Variance measures how far each value in the dataset is from the mean on average. We calculate it by taking each value's deviation from the mean, squaring that deviation, summing all those squared differences, and dividing by n1. Why squared deviations? Squaring emphasizes larger differences and ensures that deviations above and below the mean don't cancel each other out. Variance gives us a sense of overall spread, but it's in squared units, which can be harder to interpret. This brings us to standard deviation, which is simply the square root of variance. Now the result is in the original units of the data: millimeters of mercury, kilograms, centimeters, and so on. It's easier to interpret and is the most common measure of variability reported in scientific papers. A small standard deviation means data points are clustered closely around the mean. A large standard deviation means the data are widely spread out. Here's an example. Two datasets might both have a mean of 70, but one has a standard deviation of 1, and the other has a standard deviation of 10. In the first dataset, most values are close to 70. In the second dataset, values are much more spread out. This is why we report standard deviation, to give the full picture of data consistency. When should you use each? The range is quick and simple, but not very informative on its own. Variance is used in many statistical formulas and models. Standard deviation is the most interpretable and should be reported alongside the mean whenever possible. Together with measures of central tendency, variability measures give a complete description of your data. You can compute these measures easily using software. In Excel, use equals max, min, for the range, equals var.s for variance, and equals stdv.s for standard deviation. In R, use range data, var data, and sd data for these same measures. We'll practice these this week so you can apply them to real data. To summarize, variability is just as important as central tendency. Whenever you report a mean, also report a measure of spread, typically standard deviation. This helps your audience understand how consistent or variable your data are. In our next section, we'll explore how to visualize data, a powerful way to communicate variability, and more. See you there!